Hello friends, welcome to this session. Today we discuss bipolar junction transistor. Before going to start the bipolar junction transistor, we must know the diodes. What is the difference between diode and transistor? One of the major difference between the diode and the transistor is that the diode converts the alternating current into direct current, while the transistor transfers the input signals from the low resistance circuit to high resistance circuit. The diode is also known as the crystal diode because it is made up of crystals like silicon or germanium. It has two terminal diodes. The two terminal device which start conducting when the positive terminal of the supply is connected to the p-type region and the negative terminal is connected to the n region of the diode. The diode is made up of semiconductor material and it is mainly used for rectification. The conduction occurs in the circuit when the diode is forward bias. The forward bias means p-type material is connected to the positive terminal for the battery and the n-type material is connected to the negative terminal of the battery. So this is the block diagram of the diode. Here the plus sign or green shade is represented as a p-type region, while the red side is representing the n-type region, and in between the two regions there is a depletion region. So this is the symbol of or the simple diode. What is the transistor? This is the symbols and transistor. The transistor is a semiconductor device which transfers a weak signal from low resistance circuit to high resistance circuit. The word trans means the transfer of the transfer property, and resistor means the resistance property offered to the junction. In simple language, we can say that it is a switching device which regulates and amplifies the electrical signals like voltage or current. And the transistor consists of two PN diodes. As we know, the transistor has three regions, namely emitter, base and collector. Here the emitter is heavily doped so that it can transfer the heavy charged particles to the base. The base of the transistor, indicating the yellow color, is smaller in size and lightly doped. Thereby the charge carrier easily moved from base to collector region. The collector region is the largest region of the transistor because it can dissipate the heat produced at the base collector junction. And the emitter is heavily doped so that it can transfer heavy charged particle to the base. The base of the transistor is smaller in size and lightly doped, while the collector is the largest region. Simple language, emitter is the emitting the electron. At the base side some electrons are combined because due to the lightly doped, and the charge carriers easily moved toward the collector region. So collector is having largest region, so it collect the charges. Here is a simple comparison between the diode and transistor. As per the diode definition, a semiconductor device in which current flows only in one direction. While in transistor, a semiconductor device which transfers the weak signal from low resistance circuit to high resistance circuit. A simple diode is here. This side is positive, this side is negative, representing as a positive is cathode and negative is anode. While the symbol of transistor is base, emitter and collector. Here is the arrow, that arrow indicating the flow of electrons. What is the use of diode? Diode is used for the rectification, while the transistor is used for regulating or regulator, amplification and rectification. As per, the diode has the 2-terminal anode and cathode, while the transistor has the 3-terminal emitter, base and collector. Diode has the uncontrolled switch, while transistor has a controlled switch. It depends upon the biasing. What are the types of diodes? Diodes is junction diode, light emitting diode, photodiodes, Schottky diodes, tunnel diodes, varactor diodes and Zener diodes. While the transistor are the bipolar transistor and field effect transistor. What are the regions? There are 2 regions in the diode, that is the P region and N region, while in transistor 3 regions are there, that is the emitter region, collector region and base region. How many depletion region between the diode and transistor? The 1 depletion layer region in the diode, while the 2 depletion region in the transistor, because in the transistor diode is connected back to back. So that's why the 2 regions are there. Now, what is a transistor? Here our main unit, that is the bipolar junction transistor. The transistor is nothing but a semiconductor device which transfers a weak signal from low resistance circuit to high resistance circuit. It is a switching device which regulates and amplifies the electrical signals like voltage and current. The transistor consists of 2 PN diode connected back to back. It has 3 terminals, namely emitter, base and collector. The base is the middle section in which, or that middle section is made up of thin layers. The right part of the diode is called emitter diode and left part is called collector base diode. These names are given as per the common terminal of the transistor. As the transistor is 3-terminal device which is used for amplifying the electrical signals, it is made up of semiconductor material. The emitter junction is forward bias and offers a small resistance, whereas the collector junction is in reverse bias and offer high resistance. When the weak signal is introduced to the low resistance circuit of the transistor, it transfers the signal from the high resistance circuit. What is the key difference between the diode and transistor? The diode is a semiconductor device which allows the current to flow only in one direction, whereas the transistor transfers the resistance from the low resistance region to high resistance region. The diode is used for converting AC to DC or for rectifications, whereas the transistor is mainly used for amplification and as a regulator. In the diode, anode is the positive terminal and the cathode is the negative terminal of the diode. And in the transistor, there are three terminals: emitter, collector, base. The diode is an uncontrolled switch, whereas the transistor is controlled switch. That's why in transistor sometimes called as a current control device. The transistor is mainly classified in two types, that is the bipolar junction transistor and field effect transistor. The bipolar junction transistor uses both the electrons and holes as a charge carriers, and the FET is a unipolar transistor. The P-type and N-type is the two region of the diode. In transistor, the hole is the majority charge carrier in the P region, and electrons is the majority charge carriers in the N region of the diode. Among the three regions, the base is the smallest region and the collector is the largest region of the transistor. In diode, there is only one depletion region, but in the transistor, the two diodes are connected back to back. They forms two depletion layer. One is between emitter and base region, and other is in between the base and collector region. It is considered that the transistor consists two p-n junction diode, but two discrete diode connected back to back never work as a transistor. There are two types of transistor, namely as NPN transistor and PNP transistor. The transistor which has two blocks of N-type semiconductor material and one block of P-type semiconductor material is known as NPN. While if material has one layer of the N-type material and the two layers are P-type material, then it is called PNP transistor. Here are the symbols of the NPN and PNP transistor. The arrows in the symbol indicate the direction of flow of conventional current, and it is always opposite to the flow of charges. In the emitter with forward biasing applied to the emitter base junction. The only difference between the NPN and PNP transistor is the direction of the current. So this arrow indicating either it is NPN or PNP. If the arrow is directed towards the emitter, that is NPN transistor, while the arrow is directed toward the base, it is PNP transistor. And these three terminals of the transistor, namely emitter, collector and base, the terminals of the diode are explained in terms of emitter, collector and base. What is the emitter? The section that supplies the large section of majority charge carrier is called emitter. Or in simple language, it is a source of charge. The emitter is always connected to forward bias with respect to base, so that it supplies the majority charge carrier to the base. The emitter base junction injects a large amount of majority charge carriers into the base because it is heavily doped and moderate in size. Next section is that collector. The collector, words containing the collects. What it collects? The collects the major portion of the majority charge carriers supplied by the emitter is called collector. The collector base junction is always in reverse bias. What is the function of the collector? Its main function is to remove the majority charge carrier from its junction with the base. The collector section of the transistor is moderately doped but larger in size so that it can collect most of the charge carriers supplied by the emitter. Then remaining terminal is the base. This is the middle section of the transistor and that is known as the base here in the PNP and NPN. The base forms two circuits. The input circuit is connected to the emitter and the output circuit is connected to the collector. The emitter base is in forward bias and offered the low resistance to the circuit. The collector base junction is in reverse bias and offers the higher resistance to the circuit. The base of the transistor is lightly doped and very thin, due to which it offers majority charge carrier to the base. So this is the basic functions and how it forms the transistor. So this is the difference between the transistor and diodes. So today we are just take the introduction part of the transistor and compare with the diode. In next session we discuss about the working of transistor, what are the conditions required to transistor operation, like if we are taking the emitter junction forward bias and collector junction in reverse bias, then what happens? Likewise, the emitter junction is in forward bias and both the collector junction, emitter junction and collector junction both are in forward bias, then what happens? Now once we connected the emitter junction in reverse bias and collector junction in forward bias, then what happens? And both the junctions are connected or inverted, like reverse bias and forward bias and reverse bias, then what action takes place? So this method is nothing but the working of the transistor. So in next section we describe the transistor working, or what is the work of transistor, how it works. So thank you very much for watching this video.